Hello everyone, in today's video we are going to explore some key concepts of object-oriented programming, specifically in C#. We will be covering encapsulation, inheritance, polymorphism and abstractions. To illustrate these concepts, we will walk through C# program I've written. Let's get started. First, let's talk about encapsulation. Encapsulation is about bundling the data and the methods that operates on that data within a single unit or class and restricting direct access to some of the object's components. In our program, we have a base class called person. Inside the person class, we have two fields, underscore name and underscore age. These fields are marked as private, meaning they can't be accessed directly from outside the class. This is encapsulation in action, as it hides the internal state of the object. To allow controlled access to these private fields, we use public properties, name and age. These properties have get and set accesses, which are methods that get called when you access or modify the properties. This way, we control how the data is accessed and modified, ensuring that the object's internal state remains valid and secure. Next, let's move on to inheritance. Inheritance allows a class to inherit fields and methods from another class, promoting code reuse and creating a natural hierarchy. In our program, we have a class called employee that inherits from the person class. You can see this in this slide. By inheriting from person, the employee class gains access to the name and age properties and the display info method without needing to redefine them. Employee also has an additional property called salary, which is specific to employee objects. And when we create a new employee, we use a constructor that calls the base class constructor. Here, a syntax to initialize the name and age. This shows how inheritance can extend the functionality of a base class while still retaining its core behavior. Now let's talk about polymorphism. Polymorphism allows us to use a single interface to represent different underlying forms or data types. Essentially, it allows methods to do different things based on the object they are called on, even if they share the same name. In our code, the display info method is defined in the person class and then overridden in the employee and manager classes. In employee, the display info method is overridden to include the salary information in its output. In manager, it's further overridden to display even more specific information. This means that when we call display info on an object, the method that gets executed depends on the actual type of the object, not the type of the reference. This is polymorphism at work. So don't worry, I'll share this code branch with you. I'll push my changes to the GitHub repository and you can check it out from there if you would like. I'll share the link in the description box. Finally, let's cover abstraction. Abstraction is the concept of hiding the complex implementation details and exposing only the essential features of an object. In our example, we have an interface called iWorkable. This interface represents an abstract concept of work that can be implemented by any class that supports working functionality. The manager class implements this interface with the work method. The implementation details of the work methods are specific to manager, but from the perspective of the interface, any class that implements iWorkable can be treated the same way. These abstractions allow us to interact with different types of objects through a common interface. Let's see how these concepts come together in the main method. We first create instance of person, employee and manager. We then call display info on each of these objects. Notice how the output differs for each object type due to polymorphism and method overriding. Then we demonstrate abstraction by using an iWorkable interface reference to call the work method on a manager object. This shows how we can use the interface to interact with the object without needing to know its specific class type. Finally, we show inheritance and method overriding with the employee reference to a manage object, and we call display info. The overridden method in manager is called even though the reference type is employee, showcasing polymorphism. In conclusion, this program demonstrates all four pillars of object-oriented programming in C#: encapsulation, inheritance, polymorphism, and abstraction. These concepts are fundamental for writing clean, maintainable, and reusable code. I hope this breakdown has helped you understand these important concepts more clearly. Don't forget to like, subscribe, and leave a comment if you have any questions or topics you would like me to cover in future videos. Thanks for watching and see you next time.